China built a city that's only 30 feet wide. You're looking at Yanjin, a place where an entire urban population exists in a space narrower than most highway lanes. This isn't some experimental project or temporary settlement. This is a fully functioning city squeezed into the thinnest corridor of livable land on Earth. And the reason it exists this way will blow your mind. But first, you need to understand the geological nightmare that created it. Picture a canyon so narrow that sunlight only hits the bottom for a few hours each day. That's Yanjin. This city sits trapped in the Jinsha River Valley in Yunnan Province. On one side, you've got a raging tributary of the Yangtze River. On the other, sheer cliff faces that shoot up over 3,000 feet into the sky. The canyon walls are nearly vertical. We're talking about solid rock faces that rise at 80 to 90-degree angles. There's no gradual slope here, no foothills, no gentle transition from flat ground to mountain. Just straight up limestone and sandstone cliffs that look like they were carved with a knife. The river doesn't help either. It's not some gentle stream you can build around. This is fast-moving water that floods seasonally and has spent millions of years cutting deeper into the rock. The water level can rise 20 feet or more during rainy season. Between the cliff and the river, there's a strip of land, and that strip measures just 30 feet, wide in some sections. 30 feet. That's the width of 3 parking spaces lined up. That's narrower than a tennis court is wide. That's less space than most people have in their backyard. And somehow, 200,000 people live here. The geology gets worse. This region sits on active fault lines. Earthquakes hit regularly. The rock itself is layered sedimentary stone that crumbles and slides when disturbed. Landslides are a constant threat. The cliffs shed boulders like dandruff. For centuries, this valley was considered uninhabitable. The local populations avoided it. Early Chinese settlers looked at this corridor and kept moving. Even during periods of massive population pressure and land scarcity, this canyon remained empty because building here seemed impossible. But then, desperation changed everything. Why build here at all? The answer comes down to one word: necessity. Yanjin sits at the only passable route through the Wumang Mountains. For thousands of years, this narrow canyon was the gateway between Yunnan Province and Sichuan Province. If you wanted to move goods, people, or armies through this region, you went through this valley. There was no alternative. Ancient traders discovered this passage during the Han Dynasty. They carved narrow paths along the cliff faces. Loaded mules walked single file through the corridor. It was dangerous. It was slow. But it was the only way through. As trade increased, people started staying. Small settlements formed, not because anyone wanted to live here, but because controlling this choke point meant controlling commerce. Whoever held this valley held the economic lifeline of 2 provinces. Then came the salt trade. Yunnan had massive salt deposits. Sichuan needed salt desperately. The only efficient route between them ran straight through this canyon. Suddenly, this impossible location became the most valuable real estate in the region. People kept coming. The settlements grew. Temporary camps became permanent structures. What started as a trading post evolved into a town. The population swelled into the thousands, but they had nowhere to go. The canyon didn't get wider. The cliffs didn't get shorter. The river didn't move. Every single person who arrived had to squeeze into that same 30-foot corridor. By the 20th century, Yanjin had become a critical transportation hub. The national highway system needed to connect Yunnan and Sichuan. Engineers surveyed dozens of potential track routes. They all came back to the same conclusion. This canyon was still the best option, only viable option. So the Chinese government made a decision that seemed insane. They wouldn't just maintain the settlement, they would transform it into a proper city, with modern infrastructure, with permanent buildings, With everything needed to support hundreds of thousands of people, they would build the narrowest city in human history. Not because they wanted to, but because geography gave them no choice. And that's when the real engineering nightmare began. You can't build wide when you only have 30 feet. So you build up. Yanjin's architects faced a problem no other city planners had ever encountered. They had unlimited vertical space, but almost zero horizontal space. Traditional city design was useless. Here, grid patterns? Impossible. Suburban sprawl? Laughable. Even basic concepts like city blocks couldn't exist. So they reimagined what a building could be. The structures in Yanjin rise 8 to 12 stories tall, but they're not freestanding towers. They're built directly into the cliff face. The back wall of most buildings isn't a wall at all. It's solid, mountain rock. Engineers drilled hundreds of steel anchors deep into the limestone. Some penetrate 50 feet into the cliff. These anchors don't just hold the buildings in place, they transfer the entire structural load directly into the mountain itself. The cliff becomes part of the foundation. This solved the earthquake problem, sort of. The region experiences tremors constantly. A freestanding building would shake itself apart, but a structure bolted into a mountain has nowhere to go. When the ground moves, the building moves with the entire cliff face as one solid mass. It's crude, it's counterintuitive, but it works. The front of each building cantilevers out over the street below. Upper floors extend further than ground floors. This creates a stacked effect where buildings lean outward as they rise. From certain angles, it looks like the entire city is about to topple into the river. But there's method to this madness. By cantilevering upper floors, architects created more usable space without consuming more ground area. A building might occupy 20 feet at ground level, but 40 feet at the 8th floor. Multiply that across hundreds of structures, and you've suddenly doubled your city's functional space. The construction process was brutal. Workers couldn't use standard cranes. There was no room. Instead, they built scaffolding systems that climbed the cliff face. Materials were hauled up level by level. Concrete was mixed on site because there was nowhere to stage a truck. Foundation work meant drilling into unpredictable rock layers. Sometimes they hit solid limestone. Other times, they punched through to voids and underground streams. Every building required custom foundation engineering. No two structures have the same support system. Then came the windows. In a normal city, you orient buildings to maximize natural light. In Yanjin, half your building is inside a mountain. The front facade becomes the only source of daylight. So every building is covered with windows. Floor-to-ceiling glass, wall-to-wall openings. The city sparkles like a vertical mirror when the sun hits it. But that created new problems. Glass doesn't insulate well. Temperature control became a nightmare. The canyon acts like a wind tunnel. During storms, the buildings face hurricane force gusts. Standard windows would explode. Engineers had to install reinforced glass, rated for commercial aircraft. The rooftops presented another challenge. You can't have a traditional roof when the back of came. Your building disappears into a cliff. So they built flat roofs that double as terraces. These became community spaces, gardens, storage areas, emergency gathering points. During floods, some buildings go even deeper. Architects carved rooms directly into the mountain. These cave-like spaces stay naturally cool. They're used for storage, shops, restaurants. Walk into certain buildings and you move from modern concrete construction to raw stone walls in seconds. The tallest structures reach 14 stories. That's not impressive by global standards. But when you're building in a space narrower than a basketball court, 14 stories feels like a skyscraper. The buildings dominate the canyon. They block out the sky. Every square inch of vertical space is utilized. There's no such thing as setbacks or breathing room. Buildings touch each other. They share walls. They create a continuous facade that runs for miles along the canyon. From above, Yanjin looks like someone took a normal city and compressed it through a pasta maker. All the density of urban life squeezed into a single, unbroken line of concrete and glass. But buildings alone don't make a city function. You need roads, utilities, infrastructure, and that's where things got truly insane. There's one road through Yanjin, just one. It runs the entire 4-mile length of the city. It's the main street, the highway, the commercial district, the residential access route, everything. And it's barely wide enough for 2 cars to pass each other. Building this road meant solving an impossible puzzle. You've got cliff on one side and river on side the other. You can't widen the valley. You can't move the water. So engineers did something radical. They built the road on platforms suspended over the river. These aren't small platforms. We're talking about concrete decks that extend 15 to 20 feet out over the water. Massive steel pylons driven into the riverbed support the weight. Construction workers had to fight the current while sinking foundation columns 50 feet deep into bedrock below the water. The river tried to kill them. Seasonal floods arrived mid-construction and swept away equipment. Twice. The current runs so fast that divers could only work in brief windows when the water slowed. They worked in shifts, measured in minutes, not hours. But they got the pylons in. Then they poured concrete decks on top. The road literally floats above the river on an artificial shelf. When you drive through Yanjin, you're driving on a bridge that never ends. 4 miles of suspended roadway with raging water beneath you. Then came the utilities. And this is where the engineering gets truly claustrophobic. Water pipes, sewage lines, electrical conduits, telecommunications cables, gas mains, every single utility system that a city of 200,000 people needs. All of it has to fit in a 30-foot wide corridor that's already packed with buildings and a road. The solution? Use the cliff. Engineers carve channels directly into the rock face. Vertical shafts run up the cliff at regular intervals. Horizontal tunnels connect them behind the buildings. The entire utility network exists. Inside the mountain, water flows through pipes, embedded in stone. Power lines run through, carved passages you'll never see. This created a maintenance nightmare. When something breaks, workers have to access tunnels inside solid rock, behind occupied buildings, sometimes hundreds of feet up the cliff face. There's no easy way to reach anything, but it was the only option. Put utilities on the surface and you'd consume what little space existed. Bury them under the road and you'd have to shut down the only traffic artery every time. Something needed repair, so they went vertical, into the mountain. The electrical system required special innovation. You can't string power lines across the narrow canyon without blocking the view. You can't run them under the road without interfering with the river platforms. So they installed them on the cliff face. High voltage cables bolted directly to the skrid. Rock. Transformers mounted on steel brackets jutting from the stone. During storms, this becomes dangerous. Lightning hits the cliff regularly. The entire electrical system is exposed to the elements. Engineers had to design surge protection for a city where every wire is essentially outdoors. Water management presented its own horror show. The city sits at the bottom of a drainage basin. When it rains in the mountains, everything flows down into the canyon. Flash floods can raise the river level 30 feet in hours. Suddenly, your road platforms are underwater. Your first floor buildings are swimming pools. So they built a drainage system that defies belief. Storm drains carved into the cliff face. Pumping stations that can move thousands of gallons per minute. Floodgates that seal off sections of the road. Emergency overflow channels that redirect water back into the river before it drowns the city. The sewage system is even more complex. Gravity wants everything to flow downhill into the Seseret River. But you can't just dump raw sewage into the water supply for communities downstream. So engineers built a pressurized system that fights gravity. Pumps push waste uphill to treatment facilities carved into the mountain above the city. Treatment plants that exist inside caves. Biological filtration systems operating in artificial caverns. The processed water gets released far downstream. The whole system runs on backup generators because a power failure would mean sewage flooding the streets within hours. Bridges became another engineering obsession. The river isn't straight. It curves through the 5 canyon. This means the city doesn't follow a perfectly straight line either. At several points, the canyon narrows even further. The cliff face juts out. The river bends sharply. At these pinch points, there's no land at all. 0 feet of buildable space, just water and rock. So they built bridges, not across the river, along it. Bridges that carry the road past obstacles, where no road could exist. Some span 300 feet. They're not connecting 2 sides. They're just continuing the city where the city has no ground to stand on. Then there's the problem of getting people up and down. Remember, buildings rise 14 stories, but there's no room for parking lots, no space for garages. Cars stay on the single road. So how do 200,000 people access their homes? Stairs. Thousands and thousands of stairs, carved into the cliff, built into the buildings, zigzagging up the rock face. Some staircases climb 800 steps. Old residents spend an hour hiking to their apartments every single day. But China wasn't done. They installed elevators into the cliff face, external elevator shafts bolted to the rock. Glass cars that rise 12 stories while giving you a view of the entire canyon. These aren't in buildings. They're standalone structures attached to the mountain. Public elevators that anyone can use. An entire city's vertical transportation system drilled into solid stone. The whole infrastructure network operates on a knife's edge. One major failure cascades into the present. Catastrophe. A bridge collapse cuts the city in half. A water main break floods everything. Power outage in summer means no pumps and sewage backs up into homes. Yet somehow, it works. The pipes flow. The power stays on. The road remains passable. 200,000 people go about their lives in a city that shouldn't exist. And that brings us to the final, impossible truth about Yanjin. Yanjin is 30 feet wide and 4 miles long. Let that sink in. 4 miles, 21,000 feet of continuous urban development, packed into a corridor that averages 30 feet across. That's a ratio of 700 to 1. Length, width. No other city on Earth comes close. Shanghai is wide. New York sprawls. Even the densest cities have room to breathe. But Yanjin? It's a line, a thread of concrete and humanity stretched along a river that tried to make human habitation impossible. 200,000 people live here. That number sounds abstract until you do the math. 30 feet wide, 4 miles long. That's roughly 600,000 square feet of ground space for the entire city. Divide that by 200,000 people, and you get 3 square feet per person at ground level. 3 square feet. That's smaller than a closet. That's less space than you're sitting in right now. But they made it work by building up. Those 12-story buildings clinging to the cliff, they create over 7 million square feet of usable floor space. The city doesn't spread, it stacks. Layer upon layer of human activity compressed into vertical towers that turn a sliver of land into a functioning urban center. The architecture isn't beautiful by conventional standards. There's no grand design, no sweeping plazas or iconic monuments. Just practical, relentless construction that maximizes every available inch. Buildings that look like they're carved from the same rock they're attached to. A cityscape that's brutal and functional and utterly unique. Engineers proved something here that textbooks said was impossible. You can build a city anywhere. It doesn't matter how narrow the space. It doesn't matter how hostile the geology. It doesn't matter that common sense screams it can't be done. Human engineering can conquer. Geography that seems specifically designed to reject human presence. The cliff face foundations that transfer structural loads into solid mountain. The suspended road, platforms that float above an untamable river. The utility networks carved into living rock. Buildings that cantilever outward to steal space from thin air. Every single innovation was born from absolute necessity. Yanjin didn't have the luxury of ideal conditions. It couldn't wait for better technology. It couldn't relocate to easier terrain. Geography trapped it. History demanded it exist. So Chinese engineers looked at 30 feet of buildable land and said, "We'll make it enough." And they did. The narrowest city in the world isn't a failure of planning. It's not a cautionary tale. It's a monument to what happens when human determination meets impossible constraints and refuses to blink. 4 miles long, 30 feet wide, 200,000 people. One unbroken line of defiance, carved into a canyon that said no. This is Yanjin, the city that geometry couldn't stop